Welcome to Study Loop.
For this redox reaction, in part A, we're asked to identify the compounds which are oxidized, the compounds which are reduced. In order to do this, we'll need to calculate the oxidation number, and the oxidation numbers that are going to be meaningful to us here are the oxidation number of gold, which is 0, the oxidation number of O2, which is 0, the oxidation number of gold on the product side, which is +2, and oxygen on the product side is -2. We're going to not consider the oxidation numbers of sodium, of cyanide, and of hydrogen, as these, or carbon, nitrogen, and hydrogen, as these oxidation numbers do not change. So in the forward direction, we can see that gold goes from 0 to +2, so our delta ON here is +2, and this is going to be a process of oxidation. So that tells us that gold solid undergoes oxidation, and oxygen here is a delta ON of -2, so that is a process of reduction, so oxygen gas is being reduced. For part B, we're asked to write the balanced equation of AuCN2 with zinc converting back to gold. So the balanced equation here would be 2 AuCN2 minus AQ zinc solid to produce zinc CN4 minus 2 aqueous and gold solid. So there's our balanced equation showing that AuCN2 minus ion converted back to gold solid by a reaction with zinc powder. And for C, we're asked to calculate how many liters of 0.2 molar sodium cyanide would be needed to react with 40 kilogram of rocks that contain 2% of mass by gold. Well, let's start with the 2% mass. So that's equal to the mass of gold over the 40 kilograms times 100%. So if we solve here for the mass of gold, we'll get a mass of gold that's equal to 0.80 kilograms or 800 grams. And we can convert this 800 grams of gold, and the molar mass of gold is 197 grams per mole. So let's convert this into moles to give us 4.06 moles of gold. And since we know that, let's use our balanced equation here that we have from the initial part of the question. We have 4.06 moles of gold, and our stoichiometry here gives us 4 moles of gold to 8 moles of NaCN. So this would yield 8.12 moles of NaCN. And now we've got moles of NaCN. We have the molarity, which is 0.2 molar. So we can solve for the volume of NaCN. Which is equal to N over C. We have 8.12 moles divided by 0.200 molar. So our volume here would be 40.6 liters of the NaCN that would be needed.